Alright, my dear students, once again you are welcome to class. So in this module, we will be looking at geometrical ratios. Now basically in geometrical ratios, there are certain theorems that we will be considering. But before that, let us talk about what an intercept is. Now, an intercept is a point where one line cuts another. Now, a transversal is a line cutting or passing through parallel lines. And these two concepts are important for the first theorem that we'll be talking about. So the first theorem we'll be talking about will be the equal intercept theorem. Now, this theorem states that if three or more parallel lines cut off equal intercepts on a transversal, then they cut off equal intercepts on any other transversal. Now let us look at what we have here. The lines MN, KL, and GH are parallel lines. And the blue lines we have here are called transversals. That is, lines that cut through parallel lines. Now, what the equal intercept theorem is talking about is this. If we look at the transversal by the left, the distance from P and Q is called an intercept, and the distance from Q and R is also called an intercept. Now, what this theorem is talking about is this. If the distance from P to Q is the same or equal to the distance from Q to R, if another transversal, as we have on the right, also comes in and cuts through the same set of parallel lines, the equal intercept theorem states that the distance from S and T will also be equal to the distance from T and U. That is what we mean by saying if three or more parallel lines cut off equal intercepts on a transversal, for example, the transversal on the left, then they cut off equal intercepts on any other transversal, like the transversal here on the right. Therefore, we are saying that if PQ is equal to QR, in as much as we are having the same set of parallel lines, therefore ST will also be equal to TU. So that is what the equal intercept states. Now, the second theorem is the proportional division of the sides of a triangle. And this theorem states that a line drawn parallel to one side of a triangle divides the other two sides in the same ratio. If we look at this triangle, we have the base side. Now we have a parallel line inside the triangle that has divided the triangle into two. Now what this theorem is saying is basically that in as much as we are having a parallel line in the triangle, that is a line that is parallel to the base, for example, of this triangle, that the ratio of the two portions on either of the other sides will be equal. What we are saying is that the ratio of P to 6 will be equal to the ratio of 5 to 4. That is to say, P over 6 will be equal to 5 over 4. So P over 6 is equal to 5 over 4. Therefore, P is equal to 6 times 5 over 4, which is equal to 30 over 4, which is 7.5 cm. The next theorem is the midpoint theorem. Now, this theorem states that the line joining the midpoints of two sides of a triangle is parallel to the third side and equal to half of it. Basically, we are saying here, look at this triangle ABC. Point M is the midpoint of line AB, and point N is the midpoint of line AC. Now, if the line MN is drawn from the midpoint of AB to the midpoint of AC, the theorem states that that line MN will be parallel to line BC, and also that the length of MN will be half the length of BC. So let's say, and this is what the theorem states, line MN is parallel to line BC, and line MN is half of line BC. Now the next theorem is the theorem of similar triangles. Now what it states is that similar triangles are equiangular and have corresponding sides in the same ratio. By equiangular, we mean that they have equal angles, and then now that they have corresponding sides in the same ratio. So let us consider this triangle here, triangle PQR. Now if we look at this triangle carefully, we see that angle QML is equal to angle QPR. They are both 60 degrees. Now if we look at the smaller triangle, which is triangle LQM, and also triangle PQR, we can see that they both share the same angle at point Q. Therefore, if point Q for both is the same, and angle M on the smaller triangle is equal to angle P on the larger triangle, it follows therefore that angle L on the smaller triangle will be equal to angle R on the larger triangle, because the sum of angles in a triangle will obviously be 180. So such triangles are said to be similar. Now we see that angle LMQ is equal to angle RPQ. As we are given in the diagram, they are both 60 degrees. Then angle MQL is equal to PQR because it is the same angle, angle Q. Then angle QLM will be equal to angle QRP when we look at the sum of angles in each of the triangles. Therefore, we can say that the smaller triangle MQL is similar to triangle PQR because they have the same angles. Although the length of the sides may be different, but the angles are the same. Therefore, we can say that MQ over PQ is equal to QL over QR and is equal to LM over RP. All these are ratios from the larger triangle to the smaller triangles, and they are corresponding. Now, if we are to find any of the values, we can do that by simply substituting the values we are given in the question with the ones we are not given. Now, if we do that carefully, we have this. 2 over QR will be equal to 3 over 4. We were not given MQ, we were not given PQ, and we are also not given QR, but we are given the others. So we can use the second and third ratios to get the value of QR, which the question requires us to find. So 2 over QR will be equal to 3 over 4, or we can interchange the denominator and the numerator such that QR over 2 will be equal to 4 over 3, and QR will be equal to 2 times 4 over 3, which is 8 over 3, which is 2 whole number 2 over 3 centimeters. So because they are similar triangles, they have the same angles, the ratio of their corresponding lengths will be the same and equal. So my friend, that is where we are going to end the discussion on this topic. Until the next time we see, it's a bye.